So now we move on to multiplying polynomials. Okay, we're going to start with a little exercise here. And it says, consider the product x minus 2 times x plus 5. It is equivalent to one of the expressions below. Determine, right, which one it's equivalent to by substituting in the two values, right? So what they're saying is this expression here is either equivalent to this or this. Which one would it be? Now remember, if we take this value of 3 and we plug it in here, and we use correct order of operations to evaluate it, 3 minus 2 is 1, 3 plus 5 is 8, 1 times 8 is 8. So now, the question is, which one of the expressions gives us an equivalent value? Well, if I plug 3 in here, 3 squared minus 10, order of operations tells me exponents first, 9 minus 10 is negative 1. Over here, if I plug 3 in, 3 squared plus 3 times 3 minus 10, it gives me 9 plus 9 minus 10. 9 plus 9 is 18 minus 10, gives me 8. So clearly, this one is not equivalent, but this one is. Now, does this sometimes or always happen? Well, let's check. Let's substitute 5 in now. 5 minus 2 times 5 plus 5 gives me 3 times 10, which is 30. Well, now if I do 5 squared minus 10, 25 minus 10 is 15. That doesn't match up, but 5 squared plus 3 times 5 minus 10 will give me 25 plus 15 minus 10, which gives me 30. Therefore, this is showing that x minus 2 times x plus 5 is equivalent to x squared plus 3x minus 10. Okay, so that's the first part here. I should have wrote that here. So which expressions at the top of the chart had equivalent values after they were evaluated with the given functions? Okay. Explain how we could turn, right, x minus 2 times x plus 5 into that equivalent expression. Well, what we're basically doing is we're going to take this first term out and we're going to distribute it to the second binomial. So we're going to do x times x plus 5. Then we're going to take the negative 2 and distribute it to the x plus 5. So minus 2 times x plus 5. So right away that would give me x squared plus 5x. Then negative 2 times x is minus 2x. Negative 2 times 5 is minus 10. And when I combine these middle terms, x squared plus 3x minus 10. So what you have to know is you're basically doing a process that some teachers call FOIL. I don't mind using it, but it only works with a binomial times a binomial, right? But what it is if you multiply the first, then the outers, then the inners, and then the last, right? First plus the outer plus the inner plus the last gives you this expression. Okay? Now, if we had to multiply this x plus 4 times x minus 3, what I just like to do is make sure I multiply everything together. X times x is x squared. X times negative 3 minus 3x. 4 times x, 4x. 4 times negative 3 minus 12. When I combine these terms in the middle, x squared plus 1x minus 12. Okay? So when we multiply polynomials, right? So say I have a plus b times c plus d. What we're basically doing is pulling the first term out, distributing to the second binomial, pull the second term out, distribute it to the following polynomial, and then combine like terms, right? But again, some people will talk about FOIL. So A times C, that's the first. The outers would be A times D. The inners would be B times C. And then the last, right, would be B times D. And then combine like terms. Okay? So let's look at a couple of examples here. So right away when I multiply these, right, where x times x is x squared. X times negative 7 is minus 7x. Negative 6 times x is minus 6x. But negative 6 times negative 7 is positive 42. And when I combine these, I get x squared minus 13x plus 42. Okay? Now the next one, 2x times 4x is 8x squared. 2x times 2 is 4x. Negative 3 times 4x is minus 12x. Negative 3 times 2 is minus 6. Combine like terms, I get 8x squared minus 8x minus 6. Do me a favor, try the next two on your own and check your answers. So, x times x, x squared, plus x times 7 is 7x, plus 4 times x is 4x, plus 28. Combine those middle terms, x squared plus 11x plus 28. And the last one, 10x times 5x will give you 50x squared. 10x times negative 1 is minus 10x, minus 30x, plus 6. So 50x squared minus 40x plus 6. And we are done there. Okay? So now, example 5. If you were asked to multiply the following polynomial, what would be different from the examples up above? Right? So when I look at this, right, all of these, if you talk about it, like when we look at the vocabulary, all of these are binomials times a binomial, right? And when I look at this, this one is a trinomial times a binomial. And the process is no different. The only thing I want to do now is take this term, distribute it to this binomial. So I'm going to do 3x squared times 2x is 6x to the third. 3x squared times 5 is plus 15x squared. And the next one, I'm going to distribute the negative 2x. So negative 2x times 2x is minus 4x. Negative 2x times 5 is minus 10x. Then finally, 4 times 2x is 8x. 4 times 5 is plus 20. So now, combine like terms, 6x to the third, right? Then plus, this is 4x squared, sorry. It's 4x squared. So 15x squared minus 4x squared is plus 11x squared. Negative 10x plus 8x is minus 2x. Then plus 20. So using the same process, go ahead, try these two, come back, check your answers. So 4x squared times 7x is 28x to the third plus 4x squared. Then 2x times 7x is 14x squared. 2x times 1 is plus 2x. Minus, so negative 3 times 7x is minus 21x. And then minus 3. So 28x to the third plus 18x squared minus 19x minus 3. after we combine like terms. Now, the next one, when we do a binomial times a trinomial, it's really no different. But now what we're doing is taking the first term, distributing it to each of the three terms. So 24x to the third minus 4x squared plus 12x. This is going to give me minus 30x squared plus 5x minus 15. So now, combine like terms. 24x to the third. This is going to give me minus 34x squared. That's going to be plus 17x minus 15. And we are done. Okay? So the process is no different, right? Other than each term in the first polynomial has to be distributed to the second polynomial. Okay?